So in this problem, the boy throws a ball so that it may clear a wall having the height 3.6 meter. The boy is at distance 4.8 meter from the wall. That is the boy position. So it is at point A, 4.8 meter just behind the wall. And ball hits the ground on other side at 3.6 meter distance at point C. Find the least velocity of the projection of that ball. Okay. So this is the given diagram. So this is the wall. So this wall having the height 3.6 meter. Then the position of the boy is 4.8 meter behind the wall, and ball hits the ground at 3.6 meter on other side. Okay. So consider the initial velocity, that is the velocity of projection, as a v naught, and the angle of projection with respect to horizontal as a theta. Okay. So question is we have to find out the velocity v naught. Okay. And also theta is not given. So we have to find out this theta value. So for that, we will consider first motion A to B. And for A to B motion, consider the horizontal motion and the vertical motion. So point B, it is not the highest point on that trajectory. Okay, we don't know exact point, whether it is highest point. So we cannot take the velocity at point B as a 0. So the initial velocity for motion A to B in the horizontal direction. So we can resolve this. This is V naught cos theta, and this will be V naught sin theta. So initial velocity is equal to final velocity, that is equal to V naught cos theta. Then displacement from point A to B. So B is the point just above the wall. So we can take the height at that point as a 3.6 meter and the horizontal distance as a 4.8 meter. So for the horizontal motion, we can take displacement as a 4.8 meter. Then time t, just assume this as a t1 second. Now consider the vertical motion for A to B. So for vertical motion, initial velocity, this is equal to V0 sin theta. So consider the y component. Then acceleration, this is equal to minus 9.81 meter per second square. Then displacement, so point B, it is just above this wall. Okay. So it is equal to 3.6 meter. That is a displacement in the vertical direction. And time t, it is same for the horizontal motion. So t is equal to t1 second. Okay, so from this data, we can write the equation AC is equal to ut plus half at square. So for the horizontal motion, AC is equal to ut plus half at square. So this term is 0. So displacement, this is equal to 4.8 meter. That is equal to V naught cos theta into time t. Okay, so we can write t. So basically this is t1. So t1 is equal to 4.8 upon V naught cos theta. Now consider the vertical motion. So use the same equation. AC is equal to ut plus half at square. So displacement in the vertical direction. So this is equal to height of that wall, that is equal to 3.6. Initial velocity is V naught sin theta into time is t1 minus 1/2 into 9.81 t square. Okay, so put the value of t1. So You can simplify this equation. So you will get equation as 3.6. So this is 4.8 tan theta minus, so you can simplify 1 by 2 into 9.81 into 4.8 square. Okay, so this value, this is approximately 113 upon V naught square cos square theta. Okay, so consider this equation as a equation 1. Now consider the complete motion A to C. So for the motion A to C, so refer this diagram. So this is point C, this is starting point. Okay, this distance, this is equal to 4.8 and this is equal to 3.6 meter. Okay, so for A to C motion, again split that motion into horizontal and vertical motion. So for the horizontal motion from point A to C, the total displacement S is equal to 4.8 plus 3.6 meter. Okay, so that is equal to 8.4 meter. Then the initial velocity, it will remain same. So initial is equal to final velocity, that is equal to V naught cos theta. Then time t, this will be the total time for motion A to C. So you can assume this as a total time t. So from this, you will get the equation displacement is equal to ut plus half at square. So this term is 0. So we will get 8.4. This is equal to initial velocity is V naught cos theta into total time t. So t is equal to 8.4 upon V naught cos theta. Now consider the vertical motion from point A to C. So for A to C, the net displacement, this is equal to 0. So S is equal to 0. So why this is 0? Because point A and point C, they are lying on the same horizontal plane or the same line. Okay, so net displacement is 0. Then acceleration is minus 9.81 meter per second square. Then time t, it is nothing but the total time t. So it is same for horizontal motion and vertical motion. So it is t second. Then initial velocity, so this is equal to V naught sine theta. So use the equation S is equal to ut plus half at square. So from the horizontal motion, we have the equation for time. This is equal to 8.4 divided by V naught cos theta. And S is equal to, from vertical motion, this is 0. Initial velocity is V naught sine theta. Put this value of t, that is equal to 8.4 upon V naught cos theta minus 1 by 2 into 9.81 and V naught cos theta square. So try to simplify this equation. So you will get, this is V naught. Okay, we can cancel out this V naught. So this is 8.4 into sine tan theta minus So if you simplify this, 1 by 2, sorry, this is 8.4. So 1 by 2, 9.81 into 8.4 square. So this total value is 346.1 and divided by this V naught cos theta square. So it will be V naught square cos square theta. Okay. So take this equation 2. So now solve the equation 1 and 2 simultaneously. So refer the equation 1. So this is the first equation, 3.6 equal to 4.8 tan theta minus 113 upon V naught square cos square theta. Okay, so if you observe these two equations, then we have the same term tan theta and this 1 by 1 upon V naught square cos square theta. Okay, so we can take tan theta as a x and this total term 1 upon V naught square cos square theta as a y. So we can convert this equation in terms of x and y. So we can solve this as a simultaneous equation and we can get the value of x and y. So write this equation. So first equation is 8.4 x minus 346.1 into y equal to 0. And second equation is 4.8x minus 113 y. This is equal to 3.6. So this is second equation. Okay. So solve this in equation mode. So select the first equation, ax plus by is equal to c. So this is the constant for first equation, 8.4. So this is a value, this is the b value. So if you solve these equations, you will get the value of x. So this is equal to 1.749 and y is equal to 0.04247. Okay. So what is basically x? So x is equal to tan theta. So tan theta is equal to 1.749 and y is equal to 1 upon V naught square cos square theta and that is equal to 0.04247. Okay. So from these two equations, try to get the value of theta and V naught. So first equation, we will get the value of theta. So theta is equal to 60.24 and put this value in this equation. So you will get the value of V naught. So V naught is equal to 9.776 meter per second. So this is your final answer. That means if you project the object with this velocity 9.776 meter per second and with this angle, then it will clear that wall. Okay, so this is the least velocity and that is the least angle. So now we will start with the graphical analysis. So this is the last part in the kinematics of particle. So what is meaning of graphical analysis? So in the graphical analysis, the motion of a particle or object along a straight path is represented by using the different motion curves like position time, velocity time, and the acceleration time. Okay. So by using graphical analysis method, it gives very good understanding of the motion for a particle along a straight line. So with the help of these graphs, that is XT graph or VT graph or AT graph, we can easily visualize the actual motion of that object. Okay, so we can take one example to understand what is meaning of a graphical analysis. So here you can observe the problem. A particle is moving along a straight line with a constant velocity of 10 meter per second for 10 seconds, and it suddenly accelerates with 2 meter per second square for next 5 seconds. Then it decelerates with 1 meter per second square till it come to the rest. Okay, so determine total time of the travel and total distance traveled by the particle. So we will represent this complete problem by using the graph. Okay, so the first graph, it is for the acceleration and time. So you can refer the data for the acceleration. For first 10 seconds, velocity is 10 meter per second. That means it is a constant velocity. Okay, so when velocity is constant, corresponding acceleration, this value, it will be 0. So for first 10 seconds, acceleration is 0. Then after 10 seconds, the object or particle, it suddenly accelerates with acceleration 2 meter per second square for next 5 seconds. That means from t is equal to 10 seconds to t is equal to 15 seconds, particle has acceleration which is equal to 2 meter per second square. So with this acceleration, particle is moving on that straight path. Then it decelerates with 1 meter per second square till it come to the rest. That means after 15 seconds, for remaining time, particle's acceleration is minus 1 meter per second square. The meaning of minus is it is a deceleration. That is called as negative acceleration, or it is a retardation. And finally, its velocity will become 0 at a particular position. Okay. So how to represent this? By using the graph. So first graph, it is for the acceleration and time. So consider the first 10 seconds. So for the first 10 seconds, velocity is constant. So when velocity is constant, acceleration value, this will be 0. So this is the 0 acceleration. After 10 seconds, for 10 to 15, particle suddenly accelerates, having the acceleration 2 meter per second square. So you can observe on the graph of acceleration and time, this is the sudden acceleration. And that value, this is 2 meter per second square. Okay. And it remain constant for next 5 seconds. That means from 10 to 15 seconds, acceleration value, it will remain constant. So you can observe, this is the constant acceleration for t is equal to 15 seconds. Okay. Then after 15 seconds, for remaining time, particle has negative acceleration. That means its velocity is continuously decreasing. So this is the negative acceleration. So this negative acceleration, this is having the value a is equal to minus 1 meter per second square. And it remain constant for the remaining time. So this time is taken as a capital T. Okay. So at the capital T, particle's velocity will become 0. Okay. So from this acceleration time graph, we will draw the velocity and time graph. Okay. So observe this velocity time graph. So when acceleration is 0, that means particle having the constant velocity. So it will have some positive value of the acceleration. And that velocity, it is 10 meter per second. So it is given in the problem. For first 10 seconds, particle has velocity, which is a constant. So here v is constant, and that is equal to 10 meter per second for first 10 seconds, where the acceleration is 0. When there is a sudden acceleration of 2 meter per second square, so velocity will suddenly increase, okay, and it will keep increasing till the 15 second. So you can observe in the graph, from t is equal to 10 second, that means from this point, velocity will increase till the time becomes 15 seconds. So this is the continuous increase in the velocity because acceleration value is constant. So this acceleration, this is equal to 2 meter per second square, and it is a positive value. That means velocity will increase. For 15 to t second, acceleration is negative. So what is meaning of negative acceleration? Velocity of the object will decrease with respect to time. Okay. So on the velocity time graph, the velocity will be a straight line, but it is in the decreasing manner. So it is having the negative slope. That means acceleration is negative. Okay. And finally, at some time capital T, so at this point, particle's velocity, it will become 0. Okay. So this is called as a graphical method to represent the motion of the particle. So from this graphical analysis, we can find out the total displacement of the object, then velocity at a particular point, so now we will see how to find out the velocity, displacement, and the acceleration from the given xt curve, vt curve, and the at curve. So here first graph, this is position and time graph. So in the problem, if the position time graph is given, then how to find out the velocity time graph? Okay. So this graph or calculation of velocity, it depends on the differential equations. So the first equation we have, suppose we have the x as a function of time, then velocity we can find out by differentiating. So this is dx by dt. Okay. So this dx by dt, it is nothing but the slope. So slope of this xt graph. So it is nothing but dx by dt, and that is nothing but the velocity. Suppose we want to find out the acceleration, then differentiate this velocity with respect to time. So this is again a slope. So this slope, it is for the velocity and time graph. So velocity time graph slope, we will get the acceleration, and displacement time graph, we will get the velocity. So now refer, if the position time graph is given, here y-axis is the position and x-axis it is the time. Okay. And the graph is like this. Okay, so this is just an example. Okay. So if you want to find out the velocity at a particular point, let us take this point. And at this point, time is t. So at this point, if you want to find out the velocity of the object, then draw the tangent line at this point. Okay. And find out the slope of that tangent line. So this is nothing but the dx, and this is the dt. So slope of this line, so slope of xt graph, which is nothing but dx by dt, and this dx by dt is nothing but the velocity. So this is how you can find out the velocity of the particle if the position and time graph is given. So velocity is equal to dx by dt, and that is nothing but the slope of the position time graph. Now suppose velocity time graph is given. And if you want to find out the acceleration, okay. So this is the velocity time graph. So y-axis is the velocity, x-axis is the time. And at a particular point, if you want to find out the acceleration of that particle, then at this point, find out the slope of the tangent line. So this is dv and this is the dt. So slope of the vt graph is nothing but the dv by dt, and that is nothing but the acceleration. Okay, so acceleration from the vt graph we can find out. So we have to just find out the slope of the vt graph. Okay, so if the position time graph is given, find out the slope of xt. It is nothing but velocity. And if velocity time graph is given, find out the slope. So it is nothing but the acceleration. Okay. So now suppose velocity time graph is given and we want to find out the position. So suppose Vt graph is given and we are interested in the position time graph. So this is velocity time graph. And we have the initial time Ti. And this is the final time. Okay, so we have the equation velocity is equal to dx by dt. Okay, so from this equation, if you want to find out the position, then we need to integrate this equation. So dx will be v dt. Okay, and if you integrate this equation, then we will get the position. So this position at a particular point, this is equal to integration v into dt. Okay, so what is basic concept of integration? So integration is nothing but the area under that curve. So when we integrate v dt, that means we have to find out the area under the velocity time graph between the given two time limits. So here time limits are Ti is the initial time and Tf is the final time. Suppose we are interested in the position at the final time. So the complete equation will be, so I will write just the final formula. So xf minus xi, this is equal to area under the velocity time graph between the limits Tf and Ti, from Tf to Ti to Tf. Okay, so if the initial position is given, then we can find out the final position. So xf is equal to xi plus area under the Vt curve from limit Ti to Tf. Okay, so we will understand with the help of a simple example. So suppose we have the graph like this for velocity time. Okay. So initial velocity is 2 meter per second, and suddenly it becomes 4 meter per second. So this time, this is 2 second, and this is 4 second. Okay. At x is equal to, at t is equal to 2, the position is known, that is x2. So this value is 2 meter. And question is, we have to find out at t is equal to 4, what is the position of the particle. That means we have to find out the x4 value. Okay. So if the velocity time graph is given and we want to find out the position time graph, then we have to use this equation. Okay. So in this equation, xi is nothing but the initial time, position at the initial time, that is x2. xf is equal to x4. So we can write this formula as x4 is equal to x2 plus area under the velocity time graph between the time 2 to 4 seconds. Okay. So we know the x2 value, it is given 2 meter, plus area under the VT graph from 2 to 4. So this area will be this complete area. Okay. Because this is the velocity time graph, that is a straight line for time 2 to 4 seconds. So area under that line, it will be this complete area, that is a shaded region. So this area will be, so this base is equal to 4 minus 2, that is a 2, and this height, this total height is equal to 4. So area will be 4 into 2. So we will get 2 plus 8 meter. So that is equal to 10 meter. So this is the final position. So this is how you can find out the position from the velocity time graph. So we have to remember this equation. X final is equal to xi, that is the initial position, plus area under the VT graph from time ti to tf. Now similarly, if AT graph is given, we can find out the velocity time graph. So if AT graph is given, so this is the acceleration and time graph. So this is the initial time and this is the final time. Okay. So we have the differential equation, velocity acceleration is equal to dv by dt. So dv is equal to acceleration into dt. So from the acceleration, if you want to find out the velocity, then we need to integrate this equation. So integration dv, so this will become, so basically it will become v2 minus v1 if you put the limits. So from the acceleration, we can find out the velocity as acceleration is equal to dv by dt. So if you integrate this dv, so we will get v final minus v initial if you put the limit initial time and final time. So this integration a dt, so this will become the area under the AT graph from time ti to tf. Okay. So this total area, it is nothing but the integration, this is a dt. Okay. So if you know the initial velocity, so suppose at t is equal to ti, we know the value of velocity, so v is equal to vi. Okay, and suppose we are interested in the final time where t is equal to tf, what is the corresponding velocity? So this velocity we can find out by using this equation. So we will write that equation as vf is equal to vf minus vi. This is equal to area under the AT graph between the time limit, that is a ti and tf. So vf, this is equal to vi, that is the initial velocity, plus area under AT graph between time limit ti to tf. So by using this formula, we can find out the final velocity from the AT graph. Okay, so just take simple example. So if the acceleration time graph is given, and this graph is like this. Okay, so for 0 to 2 second, acceleration is constant. So this constant value, this is equal to 2 meter per second square. And from 2 second up to 6 second, so from t is equal to 2 second, acceleration is increasing, and this acceleration becomes maximum, and this maximum value, this is equal to 4 meter per second square. Okay, and suppose the initial velocity is given, which is at t is equal to 2 second, velocity v, that is equal to so at t is equal to 2 second, its velocity v2, that is equal to 2 meter per second. This is a given value, and we want to find out at t is equal to 6 second, what is the velocity. So it is a v6. Okay, so v6 will become final velocity. So this is the initial velocity, and this is the final velocity. Okay, so acceleration time graph is given, and we want to find out the velocity. So we will use the equation vf is equal to vi plus area under the AT graph from time ti to tf. Okay, so here initial time is 2 second, final time is 6 second. So vi, this is equal to v2, vf is v6 plus area from time 2 to 6 second. So v2 is given, that is equal to 2 meter per second, and this area we can find out. So this is the total area. Okay, so this total area we can divide into two known areas. So first area will be this triangle, and second area will be the rectangle. So for the triangle, formula 1 by 2, its base is, it is 6 minus 2, that is equal to 4. And for the triangle, what is the height? So it is 4 minus 2, that is equal to 2. So this is area of the triangle plus we have to consider the area of this rectangle. So for this rectangle, base is 4 and this height, it is 2. So it is 4 into 2. Okay. So in this way, we can find out the V6. So V6 is equal to 2 plus this total area. So it is 4 plus 8, that is equal to 12. So V6 is 14 meter per second. Okay. And then you can plot the graph velocity and time. So we will see this in next lecture.